hello again. So today we are going to be looking at things that are, we're going to be looking at probabilities of two things happening. And we need to be able to tell if they're independent or dependent events. So just as a reminder from yesterday, so there's a when we're talking about mutually exclusive, a bag contains 3 yellow tickets numbered 1 to 3. The bag also contains 6 green tickets numbered 1 to 6. You randomly pick a ticket. It is green or has the number greater than 2. So can those two things happen at the same time? Yes, they can. So that is not mutually exclusive. Sorry. I'm making all these videos like back to back, so it's like kind of weird. Anyway, okay. So the probability of that, I think, is most easiest found by just writing out your sample space and circling. So I've got yellow 1, yellow 2, yellow 3, and then I've got green 1, green 2, green 3, green 4, green 5, and green 6. So I have a green ticket or a number greater than 2. So that is 7 out of the 9 total. And 7 divided by 9 is 0.78. So there's a 78% chance that you would get a green one or a number bigger than 2. All right, but multiple events. Okay, so when you are finding the probability of 2 events, you find the probability of each. So the probability of both of those things happening is the probability of A times the probability of B. So you're just multiplying the two probabilities. You find them separately and multiply them together. The reason why this can be complicated is because you can have independent or dependent. So if these events are independent, what you're looking for is either they have nothing to do with each other, like they're not related at all. Wow. Okay. Not related, like they're just not related events, like rolling a die and flipping a coin. Those are two completely different things. They're not related. Or you pull a ticket out of a bag, but then you replace it. So if it says that it was replaced, then they're still independent events because you changed what happened, but you put it back. If you're looking at a dependent event, that is where you have no replacement. So you're doing something like you're changing something like pulling a ticket out of a bag or getting a sweater out of a drawer. I don't know. You're doing something and you don't put it back. So you've changed what's in the drawer. Okay. So for all of these, you're going to say, are they independent or dependent? All right. So here we go. So there's nickels and dimes. You randomly pick a coin out of your pocket and you place it on the counter. That means you did not put it back. So it is dependent. So the reason why this is tricky is because you are finding the probability that both coins are nickels. Well, the probability that you get a nickel the first time is 7 out of 11. But you've taken a nickel out and you've placed it on the table. So one of the nickels is gone. So instead of having 7 nickels, you now have 6 nickels. So the probability of getting a nickel the second time is 6 out of 10 because now there's only 10 coins left because one of them is gone. So this is something you actually have to think about. That's why probability frustrates people sometimes. You actually have to think about it. There's no just like one size fits all sort of thing. And then to get that, you just do 7 divided by 11 times 6 divided by 10. Like you can just type it in straight like that. Okay, so yeah, this one, you flip a coin twice. The first flip lands heads up and the second flip lands tails up, then heads up. So that is independent. Those two events are completely unrelated. If you flip a coin and then you flip a coin again, they have nothing to do with each other. It's the same either way. So the probability that you get tails the first time is 1/2. The probability that you get heads the second time is also 1 out of 2. So multiply those together and you get 0.25. So the probability of both happening is 25%. All right. So a bag contains 3 red marbles and 7 blue marbles. You randomly pick a marble and then you return it to the bag. So this is saying you put it back. It's been put back. So this is independent. So the probability that if you're finding that the first and second marbles are red, well, there were 3 red out of 10 total. And since nothing changed the second time, it's still 3 out of 10. So again, this is something you have to actually think about. Like, look at each problem and think, is it independent or dependent? If it's dependent, make sure that you remember that something has changed for the second probability. The total will definitely be less than 1. And if you're finding the same thing, the top number will be less than 1. If you're finding different things, the top number isn't going to, top number is just whatever it is. Anyway, okay. So there's 7 nickels and 7 dimes in your pocket. You randomly pick a coin out of your pocket and then return it to your pocket. So again, this is independent. So the probability that both, man, I'm going to change that. Okay. So we're going to say like that the first is a nickel and second is a dime. So the probability that you get a nickel first is 7 out of 14. And the probability that you get a dime second is also 7 out of 14. I wish I'd done an example that was different, but I didn't. So whatever. So the probability that those two things happen, if you do that and multiply, you get 0.25. So yeah, that's basically it. Again, if you get stuck, please ask me questions or please go find a paper tutor online. I will be trying to check Google Classroom and I can make more videos at home or I can type answers if I think it's something simple that can be typed. And yeah, that's it. All right. Enjoy the rest of your day.